Okay, so on the other side, when you are starting to do things actively, we still might go back to the passive reconnaissance phases if you, for example, discover some new information that can be fed back into those processes. But here we can use the same sources or not. Okay, so once we're in, for example, we can map client networks and identify more hosts and more systems, and it's not possible to do it not interactively. Okay, so only active reconnaissance is possible. But still, if we create if we find ourselves in a situation when we, for example, during active reconnaissance find out that our knowledge about what software and what vendors are used by the client is extended, we have to go back to passive recon and to find out more about what it is, how it can be used, how it can be misused, how it can be exploited, and so on. So this is a closed circuit here. You cannot do anything about it. You will go in circles until you finally are okay with the amount of information you collect. Okay. So what can we do? Where can we get data actively? That's are the same databases about the internet, yeah, DNS, whois records, RIPE registrations, all this stuff. But what's the difference? Here we will already automate hardly. Okay, so if you just use Maltigo, for example, in order to dig manually into what popular subdomains are registered for a specific client's domain, you are still performing a passive reconnaissance. But when you have when you take a file with a list of 1 million or 10 millions of popular subdomains in different domains, right? Ordered by popularity, or maybe not, and feed it to recon ng module that will basically just brute force your DNS server simultaneously in different threads, like in 10 parallel resolution processes, and save the results into the database as this is valid, this exists, and it has this specific IP address, and so on. It will take more time. It will be very time consuming. It will be very machine time consuming, first of all. But in the end, you will have some insight, right? So you will have something you have not expected before, and this is purely active because your DNS server, for example, at some point will resolve the information, will request the information from somewhere higher above the DNS infrastructure. So at some point it will reach to the original DNS zone file that is stored by the company or their internet service provider. Also, we can start interacting with client systems. That is really interesting. Once you find out what the systems are, you can do a lot of different things to map their functionality under the radar, right? Or you can start again discovering the content, brute forcing most popular or most frequently blocked URLs at the websites, for example, or you can just play around the various URL names that are normally used for administration in CMSs or other products. And of course, you could think about what are normal locations of different functionality in this specific product or cloud service provider, right? Nowadays, many companies move their internet services to the cloud, and this is good. Overall, it's okay because there is not a large number of companies that can maintain the same level of security as cloud providers, as internet giants, as Amazon, for example. And This is a good tendency. However, it opens all the clients, all the companies that consume these services to the similar vectors of attack. So they share a substantial area of their attack surface. Okay, so you could think of that, and next time you see that a company uses, for example, Google Apps for business to email, yeah, to provide email functionality to their personnel. You could expect that no matter what number of email addresses you will construct from publicly available information like full names, right, you will be able to validate all of them, because that's how Google Apps, Google Mail works right now. You know, you can just take a script and take a list of emails and do that. And it's not going to change anytime soon, you know. So yeah, this is the cloud considerations for active reconnaissance. Again, just to emphasize that once you get inside, you have more insight about what's going on in the networks. You get new information. You can go back to passive reconnaissance to elaborate on that data. And of course, you can go out there and meet clients, employees, meet the personnel, and observe the situation. Uh, of course, you maybe should not go as far as penetrating the physical perimeter at this point yet, at least, right? Because you have to prepare a little bit more than that. You know, just knowing the location is not enough information to try to attack it. So this is just a new or an old way to non-technically perform the reconnaissance on site. Or you can just go to a public exhibition or a conference that the client personnel would be interested in. Or you can just observe their plannings on Facebook, for example, to attend a certain event, and you can just stumble upon them with no good reason, and have a conversation and know them more, and understand what they do, what they are interested in, and so on, and elicit as much of useful information you can afford at this point without being creepy or suspicious. And you can go there and observe the situation. You can go there, you can see what the social dynamics are there, who is attending smoking areas, for example, who does not, who is late with the coffee in their hand, and who is early, and who leaves at what hour, and what's the general situation around the office. All this can be very useful in the later stages. For example, I don't know, the most valuable information you can get for nothing, right, is the mailbox of the company publicly available. Okay, so go there and see, because normally you can access that without passing a security perimeter. Even in a large business center, just go into a publicly accessible hall or foyer and just access the mailbox and can drop anything there. Okay. What tools you can use to perform the technical kind of stuff like this? Of course, there is a separate category of reconnaissance tools in Kali Linux, right? So you can play around, you can see what is there. Of course, when you are communicating with different services, you will certainly need the TCP clients like Netcat or Ncat from Nmap installation. That's essential when you are validating the emails, for example, in a script, right? You connect to SMTP port and you are trying to make conversations with the service. Of course, there is recon ng. Of course, there is burp suite that is essential in any web application penetration testing, and it has this intruder functionality that is perfect to automate web reconnaissance, right? brute forcing URL paths in Burp Suite is as simple as doing nothing. Okay, so you just create another process and you configure the number of threads and you put the input file in and you graphically design where the data from the input file will fall into the HTTP request, and you just do it and you go away, drink your coffee, come back, and have your application mapped. And there is this incredible collection of different security lists. That's what it sounds. That's security lists. It's a great, always up-to-date collection of DNS records, of possible DNS subdomains, possible passwords leaked from different sources, possible blocked URLs that you can find in many robots, TXT files, and so on. So this is including different payloads or XSS polyglots or something like this. So there are different directories to look for different stuff, and it's very systematic. That's the first thing you have to visit every time you start a reconnaissance. You just go to your directory where you store this repository and do git pull on it, because you have to be up to date with what changes are made in this repository. You can use that with tools, or you can design your tools yourself, right? You can use any scripting language, but many pen testers prefer Python because of combination of usefulness and ease of use, right? And you can use different modules like requests or DNS tools and so on. You can just create virtual browsers that will spider the websites and so on. You can do it all yourself. You of course can use Skeppy to design different TCP IP clients of different protocols. It's very flexible, but it's a whole different story. That very topic, it demands a separate series of video tutorials. But you can start playing around Python scripting right now. And of course there is Nmap. Nmap is largely used in network and service enumeration, but there are scripts and there are command line options of Nmap that allow you to do active recon as well. For example, when you are trying to map the scope, at some point you will see that there are some networks that are that contain the hosts of the client more often than other networks, right? So you will suggest that these networks totally belong to the client, right? So the client owns the network as a whole, and you will try to map the presence of other hosts in these networks, and that's where Nmap comes handy. There is an option that doesn't even use ICMP, I guess, for that in different regimes. So you will just see what's up there from very subtle TCP-based scan. And there is FOCA. FOCA is very specific, but it's essential when it comes to metadata. Okay, so of course you will have to use some sort of passive recon here and some sort of active recon. So for example, if you have a website, you can just put it into FOCA and it will find all the document files that are on this website and are cached by Google, for example, or Bing. Okay, so the search engines have found the links to these files, and there are mentions of these files in search engine caches. But in order to retrieve these files, you will have to make requests to the actual website that stores the document, right? So the first part is mainly passive reconnaissance, and the second part is definitely active reconnaissance. So there are drawbacks. That's natively programmed for Windows, so you will have a little bit of trouble trying to run it on Linux or Mac OS, but still there are ways to run it under Wine. So When you have this flavor for metadata, you will love Foca. I love it.